This is our TINKERCAD version of our 555 timer / MOSFET control circuit. This circuit is a 555 timer that is used to generate pulses that drive a power MOSFET. A diode is inserted between pins 7 and 6 so charging and discharging of the timing capacitor follow different resistor paths. When the capacitor charges, it goes through R1 forward through the diode, and when it discharges, it goes through R2 into the discharge transistor, pin 7. This forces the charge time to depend on R1 and the discharge time to only depend on R2, which produces a low-duty output, which is useful for the PWM. The output of the 555 drives the MOSFET gate through a gate resistor. The MOSFET switches through the motor supply so the motor sees pulses whose on time is set by the 555 timing. The timing capacitor C, resistor R1, and R2 set the high and low pulse durations. To verify the circuit, I measured the gate waveform with the oscilloscope in TINKERCAD, and then I also measured the resistance on the potentiometer. So since this is a 555 timer in an astable mode that generates a PWM pulses to control a motor through a MOSFET, the potentiometer acts as R1, which I set to 155 kiloohms, while R2 is fixed at 100 kiloohms, and the timing capacitor is 0.01 microfarads. Using the 555 timing formulas, the high time of the pulse is 0.693 times R1 times C, giving about 1.07 milliseconds, and the low time is 0.693 times R2 times C, which gives 0.693 milliseconds. This results in a total period of 1.76 milliseconds, corresponding to a frequency of roughly 567 Hz and a duty cycle of about 61%. Adjusting the potentiometer changes R1, which changes the duty cycle of the PWM signal, directly controlling the motor speed.